So, good evening, Professor. This is Sai Vignesh Ramsetti from Group 11. And the title of our project is Water Portability Prediction. Water is the basic necessity for every living being, but not all water on the earth is drinkable. So, it is important for us to know whether uh, a certain sample of water is drinkable or not. So these projects help us to find out whether the sample of water given is drinkable or not based on different features of the water. So let's get into it. Actually, this portability is based on many qualities like pH, hardness, sulfates, solids, trihalomethanes, turbidity, etc. So the main aim of this project is to train a model which decides whether water is drinkable or not based on these features and the values given to this. So let's get into the code. As you can see, the first part of the code is deliverable 1 and I have explained it completely in the first video, but I will give you a brief explanation. Let's get into the code. The first part of this is just importing all necessary libraries. Then we have to import the data that is set stored locally in our computer in form of CSV. Here I imported the data from my downloads folder, which is named as waterportability.csv. Here, as you can see, the MSNO missing no dot matrix. This line is used to find all the missing values in the dataset. As you can see here, the black strips are the filled values, and the white strips that are in between the black strips are the missing values, or otherwise we can call them as null values. So here we are using dropna feature, actual dropna command, so that we are dropping the whole row in which the null values are there and eliminating from the dataset we are using. This increases the accuracy of the data. And after dropping that, as you can see in this graph, there are no null values to reduce the accuracy. Then here we use this command to count how many number of ones and zeros, that is portability and not portability in the portability column of the dataset. There are 1200 zeros and 811 ones. This is not a big of a issue because there is no big difference between that. But if there is a big difference, then the model will not be on balance. So to make it on balance, here this is just a graph to show that zeros are more than 1. To make it a balance, here we are dividing the CSV file, that is the dataset, into portable dataset and not non-portable dataset, and we are resampling the portable dataset to match the size of the non-portable dataset. So after that, we just recombine the both the datasets to get the final dataset, which has 1200 ones and 1200 zeros, which restores the balance of the dataset. So from here these are just visualizations of different values, portable of different values like turbidity, hardness, and other features of the dataset of different water samples. So let's check here. This is the dataset. This is the value between. Sorry, this is the graph between pH and portable and non-portable column, and this is the graph. This is a box plot to find outliners. The data of pH value is also described here. This is completely the data of the pH values. And coming to here, this is just a normal distribution curve. There is an another graph which shows the link between hardness and portability and non-portability of the water samples. And as you can see here, this is just a scatter plot which between potability and hardness of the water. So this is a heat map which shows the correlation between every feature of the water with the other one. So this is just one, because if we show the correlation between pH and pH, it becomes as one. So we have to focus on these purple color boxes, as this shows the correlation between two different features. So till now it's the first deliverable. As I explained it in the first video, I just went a bit fast. Sorry for that. And coming to the second deliverable, which starts at line 24. Here we have to train and test the model using dataset. First, we have to import the required libraries. Here we imported the required libraries from sklearn model selection and sklearn assemble. These libraries are imported in the first line I showed in the deliverable. So from here, the training and testing of data starts. Here we are splitting the data into 90% and 10%. That 90% of the data is used to train the model, and this 10%, that is 0.1% of data, is used to test the model. So first we took random forest classifier model and we are developing this. Here the first we took so then we train and test the data to get the accuracy of this model. So after we train the data with 90% and test it, we have to find the accuracy. So the accuracy for this random forest model is 82%. This is for the test data, and for the training data it's generally not necessary, but we just added it. It's 100% because it is trained with this data. So this is all the classification detailed report of the of this training and testing and finding the accuracy of this model. This is the detailed report of it, which is also not necessary, but we added it for more clarification. Yeah, till here the random forest is completed. So here let's see whether we can predict if a sample of water is potable or not. Here we gave different values for these features of water, that is let let's say pH, water turbidity, solid, sulfates. We gave different values for these, and we are trying to predict whether a water sample with these values further features is potable or not. So we wrote an if-else condition, whether if-else condition, if A is equal to 0, that is if the potability value is equal to 0, then the water is not potable, and if A is not equal to 0, then it is potable. As you can see here, for these values the water is not potable. So let's go into the SMV model. Here, this is just like a random forest. We took a different model and we developed SMV model. SMV model trained it and we tested it. So the accuracy of SMV model is 69%, and this is the detailed classification report of this SVM model. Sorry, SVM model. So coming to the third model, this is logistic model. Here we train the data and test it, and the accuracy is just 49%. As you can see, the accuracy is getting reduced in logistic model and SVM model. So the fourth and the final model we developed is decision tree, and here the accuracy for training and testing data is 76%, which is better than SVM and logistic model, which are very less than compared to this. So this is the bar plot. This is the final bar plot which is used to compare between four different models and find out the best model to predict whether the water is potable or not. As you can see here, this is just the training data set accuracy, which is not taken into consideration. This is the testing data accuracy. So here the accuracy of random forest is almost more than 80. That is, let's see here. Um, yeah, it's 82%, and the accuracy of SMV is 69%, and the accuracy of logistics is less than 50, that is 49%, and the accuracy of decision tree is let's say 76%. So from this bar chart and the above details and accuracies, we can confirm that random forest classifier model is the best model to find out whether the given water sample with different features is potable or not according to the values of those features. So this is our total project, and the main output of this project is that we found which model is much more better for this portability system. And the second main output is we can predict whether a given water sample is potable or not if we have the values for these features. So as you can see, we gave different values for these features and it shows non-potable. If we change these values, maybe the water may be potable if we change some of these values. So these are the two main outputs of this project, and this is our project and the final output. So thank you.